One of those things we missed here recently on a machine and didn't realize that the battery was not being charged until we were almost ready to release the machine back to the customer. So I wanted to kind of go through the procedure for checking the charging system on a Kohler engine. I'm sure all of the other engines are pretty similar, but the Kohler engine is the one that we have more of the issues with. So one of the tests is we want to verify that the battery itself is in good shape. And we have a cheap $40 device here that will tell us pretty closely what kind of shape the battery is in. And so what we do is we just clamp this on, and it gives us what the voltage is in the battery, which the battery is up to a good voltage there. It's charged up well. So what we're going to do is we're going to select the type of battery that is in there, which is just a normal battery. And then we enter how many cold cranking amps this is, and this battery notes that it's 425 cranking amps. And then we tell it to test that, and it reads it's 296 cranking amps is in the battery. And it has a little green or a little red light here that says that it failed the test. It failed to give us the proper cranking amps for that battery. So before this goes back to the customer, we're going to verify, okay, do you want to buy a battery from me, or do you want to pick one up, maybe get this one returned for warranty or something. So with that said, we know what kind of shape the battery is in. It does start the machine. It will work, but we like to make sure that they're going to work continuously on the job and not just fail. So the second thing that we like to test on these engines is it charging? And the way that we can test that is we're going to set our meter for DC voltage, and we're going to test what voltage is the battery at now, which we saw that it was about 12, okay, it's 12.8 volts. So what is it going to be whenever we rev it up? And it should be between 13.8 and about 14.5 volts. That is a proper high-end charging voltage for the regulator and the alternator on this. So let's fire it up, get the engine running at a good RPM. That's 14.1 volts. So it's still 14.1 volts. Okay, so this unit is charging. So some of the things that we would look at if the machine was not charging would be the regulator rectifier. So one of the issues that we see, not on a regular basis, but more often than not, whenever someone may have to remove this cowling for maybe getting some debris out of the flywheel, or maybe replacing the screen on that, or whatever. Whenever the mechanic will remove this regulator from the cowling, or remove the cowling from the engine, they have to unplug this wire. And since this regulator is metal, and the metal is mounted to a plastic cowling, it has to have a metal wire, a copper wire, or a metal plate. This is what they used on earlier models, to ground the regulator to the base of the engine to give the regulator a negative. The positive is this purple wire in the center of this loom here, on this here where my finger is. So that's going to be hot. That will be a 12 volt, runs directly to the battery. So whenever you're looking at one of these and it does not have this black wire on it, or it does not have this metal plate, which would be mounted on the bottom down here, it's not grounded. So you could put a ground wire on it and it would probably charge. The last thing that you would want to check is to see if the stator itself is putting out voltage. Now the stator is going to put out AC current, AC voltage at about 32 volts, anywhere between 28 to 32 volts. And then the regulator will change that, will convert it from alternating current to DC current. So what we're going to do is we're going to fire this engine up. We already know that this one is charging, but we're going to verify what the voltage is coming out of the stator. Now there's only 3 wires here to contend with. We have the purple wire in the center, and then the 2 outside wires is where our AC current is going to be derived from. So what we're going to do is we're going to set our meter to AC voltage, and we're going to put our terminals inside of here. We're going to fire it up and we're going to see what our AC voltage is there. We actually have 37 volts there. So our stator is working. It's putting out 37 AC volts. The regulator is grounded. The regulator does have 12 volts going to it. The regulator is grounded. So that's why this whole system is working, because everything is done properly. So that kind of gives you the full process of testing the battery. Is the battery co-cranking amps proper? Is the regulator wired up properly? Is the regulator grounded? Is the stator putting out? In this case, all things are yes. So on the machine that I just talked about that we almost put back into service, I'll show you what we found. Whenever we tested the voltage on it, it was not putting out any voltage at all. It was not putting out any AC voltage. So we removed the flywheel, and we found that all of the magnets had become delaminated. They're glued to the inside of the flywheel, and either the glue had failed and the magnets had come loose and they got wedged between, this is the stator, they got wedged between the stator and the flywheel magnets, and it just ripped the magnets out, and you can see the stator was compromised also. So there's only 2 wires coming out of there, and that's the wires that we were testing for the AC voltage. So we were able to catch this before it went back into the field. That would have been pretty embarrassing for us, but hey, we try to catch all we can.